Hey guys, today we're going to talk about air masses and fronts. So let's get started. Now, air mass is a large body of air with similar temperature, humidity, and air pressure. Air masses are able to form over large land or water masses. Now, there are four types of air masses that will be discussed today. They include tropical, polar, maritime, and continental. Now, tropical air masses have warm air masses that form over the tropics. With polar air masses, you have cold air masses that form over the poles. With maritime air masses, the air masses form over the ocean, and these are usually very humid. And finally, with continental air masses, they form over land and are dry. Now, the word continental literally means land, and it refers to air masses that form over land. Maritime air masses refer to air masses that form over water. Maritime means water. Polar air masses refer to the poles, a region that's cold, so therefore polar means it forms over the poles. Tropical air masses form over the tropics. This is located near the equator. Therefore, tropical air masses are warm. Now here's a map depicting the various air masses that might have been mentioned. Notice there are a couple of types of maritime masses. There is also a few continental air masses that of note that you might want to kind of be aware of, especially when you look at the region of the United States that we live in. So that's those. And now we're going to go ahead and transition into talking about fronts. Now, with fronts, they refer to where air masses meet but do not mix due to differences in their temperatures and densities. And as I go through talking about these various fronts, you'll see how something such as temperature and density can impact their interaction with one another. So let's get started. We have four types of fronts. We have a cold front, a warm front, an occluded front, and a stationary front. And each one has a different list of things that occur. They have different color designations that can be evidenced on their map, and different things occur during these different types of fronts. So we'll talk about them. First, we're going to talk about the cold front. Now, with the cold front, you have cold air mass that is replacing the warmer air mass. And that can be shown on the weather map by the blue line with the triangles pointing the direction the cool air is moving. Because the cooler air is more dense and heavier, it tends to go underneath while the warm air naturally rises. And so when you have a cold air front, anywhere the direction is going, it causes those warmer temperatures to cool down. So to kind of recap that information, during a cold front, you have rapidly moving cold air mass and it runs into the slowly moving warm air mass. And because it's moving, it's able to kind of push that warm air mass. Now, the denser cold air slides under the lighter warm air and it pushes the warm air up. The rising air cools and condenses and consequently forms clouds, and you usually see heavy rain or snow may fall, or if the warm air masses contains only a little water vapor, there may only be cloudy skies. Also, cold fronts move quickly and can cause abrupt weather changes, including violent thunderstorms. And after a cold front passes through, usually cool, dry air moves in. Uh, you have clear skies and cooler temperatures often following the cold front, all of which are kind of mentioned on the first slide about cold fronts, but you want to keep that in mind. Also, you want to keep in mind that the cold air front usually is heavier, more dense, and it tends to go underneath. So let's talk about the cold front in the snapshot. It's the zone where cold air is replacing warmer air. So if you had to define cold front, it refers to that zone where the cold air replaces the warm air. And in the image provided, notice I had those triangles again, and the triangles point to the direction that the cold air is going to show you that those warmer temperatures are going to eventually become colder. And so if you look at the other image where it has 38 circled and you look at the 55 to the right, what it's depicting when you have a cold front moving in, that 55 will actually decrease. and air gets drier after a cold front moves through. So let's talk about a warm front. Now, the warm front's a little bit different. Uh, the warm air mass collides with a slowly moving cooler air mass. If you look at the weather map to the right, there's a red line with half circles pointing in the direction the warm air is moving. And so when you have a warm air front moving in, it tends to cause the temperatures to increase, so to speak. And if you look at the cross section on the bottom, you see that the warm air, although warm air rises, is actually got enough momentum or force that it's pushing that cold air kind of out the way, so to speak. So moving warm air masses collide with a slowly moving cold air mass. The warm air moves over the dense cold air. If the warm air is humid, showers and light rain fall along the front where the warm and cold air meet. If the warm air is dry, scattered clouds form. Because warm fronts move more slowly than cold fronts, the weather may be rainy or foggy for a few days. After the warm front passes, the weather is likely to be warm and humid. In winter, warm fronts actually bring in snow. Of course, we probably won't see that if we're in the south as much. Now, to kind of capsize or abbreviate this definition of a warm front, it's the zone where warm air is replacing cold air. And during this time, air actually gets more humid after a warm front moves through. And notice the line with the red half circles. And anywhere you have a warm front, the temperature is actually going to increase. So if you look at where it's a 71 circled on the right image, and then if you look above that where it's 53, that 53 temperature is actually going to increase during a warm front. So let's go ahead and compare the warm and cold fronts a little bit to kind of get a gist of uh, differences and sort of things that make them interact with one another. So first, cold fronts move faster than warm fronts. The weather activity in a cold front is often violent and happens directly at the front. Cold fronts have sudden gusty winds high in the air, creating turbulence. The weather activity in a warm front generally happens before the front passes. And in a warm front, the cloud formation is very low, often creates situations of poor visibility. So these are kind of things that compare the warm and cold front. Now, let's talk about occluded fronts. Now, when a warm front is trapped by two cold fronts, it's kind of sandwiched in there, and we'll see a little bit more of that later on. You get the occluded fronts. And if you look on the weather map, it's evidenced by the purple line with alternating triangles and semicircles pointing the direction the front is moving. So it's kind of a combination where they both are kind of colliding, and it pushes the warm air upward. So in an occluded front, a warm air mass is caught between two cooler air masses. Thus, the picture of the Oreo below, example of it kind of being sandwiched. You get it. So the denser cool air masses move underneath the less dense warm air and push it upward. The temperature near the ground then becomes cooler. Now, the warm air mass is cut off or occluded from the ground. It's kind of hoisted up, so to speak, so it doesn't even touch the ground at all. As the warm air cools and its water vapor condenses, the weather may turn cloudy and rainy or snowy. Now, to capsize this definition or make it small, we're going to define it as being um, formed when a cold front overtakes a warm front. So that's the shortened definition of it. And these images to give you a better depiction of what that looks like on the map. Notice the purple one is the occluded front, and basically it looks like a combination of the red and blue fronts from the cold and the warm front. So that's what the occluded front looks like. And it points in the direction of where it's happening. Now, this occurrence usually results in storms in an area. In the United States, the colder air usually lies to the west. So people on the east, you're a little bit safer when you have an occluded front. All right, stationary fronts. This is a front that stops moving or is moving very slowly. When shown on the weather map, it has alternating red semicircles pointing away from the warm air and blue triangles pointing away from the cold air. And so it's kind of like their collision is completely stopped or they're not moving that much. You might refer to it as a standoff, and I can show you there by the image. Sometimes cold and warm air masses meet, but neither has enough force to move the other. Therefore, you have your stationary fronts, which basically mean they're in a standoff. During stationary fronts, it's where the warm and cool air meet. Water vapor and air condenses into rain, snow, fog, or clouds. It may stall over an area and bring many days of clouds and precipitation. So, with the stationary front, it's shortened as a definition to mean when either a cold or warm front stops moving. That's the short definition. And here the image depicts what stationary front looks like. You have the blue triangle and the red half circles, and they're both pointing in different directions, pointing away from the warm air and pointing away from the cold air, respectively. And when the front starts moving again, it returns to either being a cold or warm front. So we're going to look at this map here and then kind of get a general idea or maybe practice locating the four types of fronts on this weather map. And I mean, this obviously could be any image from the Weather Channel. This one's from long ago, but if you look at it, you see there are different types of fronts being represented. So hopefully we can kind of use this to kind of gauge the type of fronts that are visible. Now, hopefully you can identify the four types of fronts in this map, but if not, we're going to go through them and kind of review it as I proceed in the PowerPoint. So let's go ahead and do that. So let's look at where's a cold front. Where a cold front might be represented. Well, we kind of know that cold fronts, hopefully we know that there's a blue color that's evidenced by cold fronts. Hopefully we know that there is a blue triangle that goes with them. So hopefully we can label them as needed. So yeah, there's a cold front example. There's another cold front example. So cold fronts have the blue, not circle, excuse me, the blue triangle, and they have a blue line, and they're pointing in the direction that the cold front is going. So if you look at the map, California is receiving a cold front, and the areas of Alabama, Tennessee, parts of Georgia may receive some of that cold front. So that's what you should see. All right, there's also a cold front in the ocean. And as you can see there, it's pointing in the direction of the Atlantic Ocean. So let's talk about warm fronts. If we know of anything about warm fronts, we know they're not blue. Um, and we should be aware that they kind of look like half circles and they're red. So those should be evidenced by this circle here as warm fronts. So let's talk about stationary fronts. Stationary fronts are not warm and they're not cold fronts, and they refer to those fronts where neither the cold or the warm are giving much leeway. And so looking at the map, hopefully you see that that area down in the bottom of the map is the stationary front area. And eventually one of these is going to move and become either a cold or a warm front. Now, lastly is the occluded front. And the occluded front is not like the warm, not like the cold. It's not like the stationary. It actually takes on the purple color and it refers to the has the triangle and the half circle. And in that sense, you kind of have the sandwiching, excluding the warm current. So hopefully you can kind of label that. And it's evidenced by the one that has the purple color. So that's your occluded front. And so let's go ahead and take it a step further and be a weather forecaster for me. And let's say you are planning to travel to Georgia in 2 days. And let's say, I don't know, you're coming from the northern part of the United States, maybe, I don't know, Michigan, or you could be in Montana or anywhere that's not in Georgia, basically. Let's say you're going from Ohio or Indiana and you're going down south to Georgia. The high temperature there for today is 68 degrees Fahrenheit. what's likely going to happen over the next 2 days. Well, if you guess that there's going to be a cold front moving in, you would be correct because there's a blue line of triangles that kind of show as evidence. So that completes pretty much our presentation on air masses and fronts. Hopefully you garnered or gained some new knowledge about air masses and fronts. And that's it.